Hello friends, my name is Tejendra Jangad. Here I am discussing the objective solution of P.S.Bimbhra for from question number 11 to question number 20 for DC machine. Next video is coming soon for the polyphase induction machine, and coming soon solutions are power electronics for P.S.Bimbhra, EMFT, Matthew and OSIDQ, electromagnetic SOMS outline series and many more. So don't forget to subscribe. Anybody can download education, that is ABCD education. Okay, now come to the question number 11. The armature core of the DC machine is laminated to minimize hysteresis losses, eddy current losses, mechanical losses, temperature rise. Now come to the solution. As we know that the eddy current is directly proportional to the frequency square, magnetic field square and thickness square. By using the thin iron pieces in the armature, we reduce the eddy current. Okay, now these are the eddy current like this. Okay, which are flow in this direction. So these are reduced by increasing the resistance between the armature. So it is divided into many substrate like this. Here the five substrate we use to reduce the eddy current. Okay, now the eddy current flow in this direction, in this way. So these are divided 1 2 3 4 5 substrate. Now the resistance in between the in the eddy current is increased. Due to the increase in resistance, eddy current are reduced, so the eddy current losses are reduced by using this. So the answer B is correct. Now come to the question number 12. The commutator segment of the DC machine are made up of brass, copper, hard-drawn copper, copper alloy. Now come to the solution. This is the simple question and we have to remember these things. So the in commutator segment we use hard-drawn copper. Okay, so the answer C is correct. Now come to question number 13. The consider the following statement regarding the DC machine. The statement are: possible resistance of the shunt winding is 1 ohm, possible resistance of the series field winding, that is 1 ohm. Electrographite buses are used for the 230 volt 10 ampere machine. Copper graphite buses are used for the 230 volt 10 ampere machine. Possible armature resistance is 1 ohm. Now these are the option. Now the correct statement are. Now come to the solution. As we know that the armature, as we know that the field circuit resistance is very high, okay, but less than the critical resistance. Okay, so it is not like 1 ohm, so that is the correct, but that is the incorrect option. Okay, now the statement second, the possible resistance of the series field winding is 1 ohm. Yes, series field winding resistance is very low. Okay, so the statement 2 is correct. Okay, now electrographite buses are used for 230 volt 10 ampere machine. The apparent density, strength, hardness and resistivity can be closely controlled through the raw material composition and processing to achieve the superior commutating ability while providing long life. That is possible only in only case of electrographite buses. So we use electrographite buses for the 230 volt 10 ampere machine. So the statement 2 statement 3 is also correct. Now come to the statement 5. We know that armature resistance, here armature resistance is very low. Why? So the statement 5 is also correct. So the statement 2 3 5, that is option B is correct. Now come to the question number 14. A 4-pole DC generator run at a 1500 rpm. The frequency of current in the armature winding is 25 hertz, 50 hertz, 0 hertz, 100 hertz. Here the 4-pole DC machine. Okay, so the speed 2 pi n rps, that is in radian per second. Now it convert into rpm. 2 pi n divided by 60, then it will convert in rpm. That is the mechanical speed. Okay, we have to remember this. Okay, now we know that speed, we know that the here we use 4 pole. So the electrical speed should be equal to mechanical multiplied by pole by 2, where pole is 4, and this that is equal to 2 pi f, where f is the frequency. Now put the values of p n. Okay, now we get the frequency 50 hertz, not a 25 hertz. That is wrong. Okay, so the answer b is correct. That is wrong. Okay, 50 hertz is the correct answer. Okay, now come to the question number 15. In normal DC machine, the operating at a full load condition, okay, the most powerful electromagnet is field winding, armature winding, interpole, and compensating winding together. Now come to the solution. This is the simple question. Okay, so in the DC machine, only a field winding. This is the field winding, which produces useful flux to run the DC machine. So it is the powerful winding. Here we know that these voltage buildup characteristics start voltage increase by the help of field circuit. When field circuit is available, then the voltage buildup is possible. So the only field winding is very powerful winding. So the answer A is correct. Now come to the question number 16. A self-excited shunt generator fails to build up because the the field circuit is open, armature circuit is open, residual magnetism absent, and the direction of rotation is wrong. Now come to the solution. As we know that if the field circuit is open, then the voltage generator Eg equals to K and phi residual and no load speed. Okay, so the Eg is generated only due to the residual magnetism, okay, which is present in the field. So that is voltage buildup is not possible when the field circuit is open, so voltage generation fail. So the statement 1 is also correct. Now come to the statement 2. The armature circuit is open. When the armature circuit is open, then the armature current is not flow. If the armature current is not flow, then the armature field is also not developed. So when the armature circuit is open, then the armature field is not developed, so the voltage generation is failed. So the it is also a reason to fail the generation of voltage. So the statement 2 is also correct. Now third statement, as as we know that the residual magnetism is not present, it is absent, then the voltage buildup characteristics is not started. Okay, the voltage buildup characteristics is started when only and only when the residual magnetism is present. If the residual magnetism is not present, then we have to produce the residual magnetism by applying the DC field to the field circuit. Okay, so this is also a reason to fail the voltage generation. So the statement third is also correct. And the fourth statement, the direction of the rotation is wrong. As we know that the E equals to K and phi. If N is reverse, then E is also reverse. Okay, that is, if the direction of the rotation is wrong, then the E is reverse, then the IF is also reverse. Due to this phi residual, that the residual flux will destroy, so it fails to generate the voltage. So that it is also the reason to fails the generation of voltage. So the statement one, 2, 3, 4, both all statement are correct. So the statement option C is correct. Now come to the question number 17. A DC generator builds up 230 volt when driven in a clockwise direction. Okay, in case it is driven in the anti-clockwise direction, other things remaining unchanged, then the voltage buildup is here. In case it driven in the anti-clockwise direction, the other thing remaining unchanged, the voltage buildup. So this is the simple question. As we discussed in the previous question, if the direction of the rotation is reverse, then the E will be reverse. That is, the direction of the rotation is wrong. Okay, so the E is reversed due to the field current is also reduced, also reversed. Now if the field